So welcome to our meetup on decentralized community internets. I know there's just a few of us, but I wanted to introduce everybody to, or invite everybody to introduce themselves in the chat. Usually I like to name a few sentences about what brings you here, what's exciting to you about this talk, or as much or as little as you'd like to say about that. I know it's a little awkward on a Zoom call because you can't really do side channel conversations as easily, but it'd be really nice if we can have this be kind of a community building space rather than just a lecture type space. So feel free at any point to use the chat. We do have etiquette, pretty standard stuff. Zoom, please mute yourself while others are speaking. Most of the time Esther is going to be speaking, so that's pretty uncomplicated. Although I'll tell you this tip in case you haven't already found it, if you're muted and you hold down spacebar, you can temporarily unmute yourself walkie-talkie style. And that might be helpful if you have a clarification during Q&A section. We do have a code of conduct, and it is here. And it's pretty standard in terms of just treating each other well. If you see anything that you feel uncomfortable with, your hosts here are me, Cameron, and Jim. And feel free to private message any of us if there's anything you want to flag or talk about. We will have a Q&A session after the presentation. If you write questions in the chat while the presentation is still going, we'll actually collect them and then I'll be able to moderate them, try to make it flow a little bit better after the presentation's over. So feel free to put those in at any time. And there will be a couple of minutes at the end if anybody wants to take the floor. We're calling this community minutes. And it would basically be, hey, I'm working on this, or this is a project that I've heard about, or an update. Something that takes really about 1 minute to talk about. You're welcome to do it. It's experimental. If nobody wants to, that's also fine. But you can flag that in the chat as well if you'd like to. And without further ado, I'd like to introduce Esther Zhang. She is a fourth-year PhD student in Information and Communication Technologies for Development at the Allen School of Computer Science and Engineering at the University of Washington. She has worked on building community-centric wireless infrastructure in Mexico, Peru, and the Philippines. And her latest work is here in the Puget Sound, where she's working on better digital access for Seattle and Tacoma's lower access neighborhoods. All right, Esther, I'll get your slides up and you can take it away.
Cool, thanks. Hi, everyone. I'm Esther. I'm a PhD student at UW. I'm actually in my lab right now. And I guess I wanted to introduce this project that I'm working on out of the lab, but also the nonprofit that we started like for this project. It's the Seattle Community Cellular Network. So the talk is called Building Decentralized Community LTE Networks. Next slide. So the activities of our lab mostly center around internet access for rural and developing regions. And so kind of our academic home base is in international development. We've worked in small rural villages, and we basically developed technology for low income, kind of what Google and Facebook would define as emerging markets. And so one of the things that my advisor, Curtis Heimerl, noticed during his fieldwork were that cellular networks were really kind of a very necessary and basic thing that wasn't present in a lot of these rural village contexts. So while there were already kind of mesh networking and other decentralized wireless technologies that you can deploy in these regions, he was thinking, okay, maybe we should work on cellular networks. So this became a strategy for rural remote internet access. And here you can see a couple of deployments our lab has been involved in. So on the left is a 2G network that we deployed in the Philippines in 2018. In the middle, there's a 4G LTE network that we deployed in Indonesia in 2018. And on the right is another LTE network in Mexico in 2019. And all of these were super successful because really, like in some of these lower income areas, the primary mode of computing is through your mobile phone. And so people, had smartphones and didn't necessarily have computers or other Wi-Fi devices. And so the concept was to bring, these cellular networks to the urban context that we have here. Next slide. So I guess to review some of the reasons that we would choose cellular networks over some of the current technologies for decentralized networks are that it's possible to get a super wide area coverage in comparison to some of these, Wi-Fi networks. So you have like higher power transmitters. These are usually pretty high-powered radios that have, can potentially have miles of coverage. You can see in the picture on the right, it's a map view of part of the UW campus area and some of the surrounding area. And we were actually able to set up a cellular network that had line of sight to this playfield marked by the X here. So that's a distance of 1.3 miles, and we had a cellular receiver on the other side. And so using our LTE network, this receiver, which is called a CPE, I'll explain that more later, consumer premises equipment. It's basically a fixed wireless receiver for the network, and it was able to get 60 megabits down and 8 megabits up from a original connection back at our LTE network of about 150 megabits per second. So it's pretty good at long distances. You also have per access point, you can get a lot of users. So the ones that we use are 96 users. And these base stations are designed to handle loads of users at a time. And the network is also designed for mobile phones. So you can get a pretty wide coverage area around each access point of about half a mile using a regular smartphone. But there are also other kind of interesting technological features of cellular networks, including the SIM card-based authentication, where like let's say I'm an organization and I want to have a very strict privacy on my network, then I can make sure that you can't authenticate to the network without my hardware token. So that's an interesting feature that could potentially be exploited. And also, it's really interesting to study cellular networks because you feel like you're looking into the mouth of the beast. Like you could potentially more about how like Comcast and AT&T, and actually probably AT&T, Verizon, like those kinds of carriers work, and you're essentially like taking over their functionality. You're like taking it back. So these are some of the reasons we like cellular networks for internet access. Next slide. This is just a fun picture of my coworker Matt holding one of these CPE, consumer premises equipment, fixed wireless devices. And then in the circle there, that's actually where our LTE access point is, mounted on the roof of this building that I'm in. So this illustrates that also it usually helps to have a second pair of hands involved in any given fieldwork or site visit, which is one reason why this kind of networking is fun, and we need more people to help out. Next slide. So for this rural use case that I was talking about, we really need these cellular networks to work disconnected from the rest of the internet, because in some of these rural remote areas, it's really hard to get that connection back. Like in LTE, everything works over IP routing. You don't have like a circuit-based call mechanisms like in previous phone networks or telephony networks. But even so, you may have like a very slow or unstable connection back to, you need to get your packets back to the internet basically. And you may have a very slow or unstable connection over a satellite link or over a long distance wireless hop. So if your network becomes disconnected from the wider internet, it still needs to work inside of the network, like for local calls, local, functionality. And in order to do that, we really had to decentralize what's called the core network of the cellular stack. So the core network, or in the case of LTE, the evolved packet core, the EPC, keeps track of all the user identity and the authentication credentials. It can coordinate between multiple base station radios, so you can have 2 radios pointing in different directions attached to the same core network, and basically routes all traffic. And so if you can't do any routing without going, to the internet to some remote cloud EPC, then you can't function without that internet connection. And so our lab built off of an open source LTE stack called Open5GS, which used to be called Next EPC, and we forked and maintained that. But that's basically what we deploy, which moves the core network to the edge. So this Open5GS project is now currently moving towards 5G. So it used to be called Next EPC for 4G, but now it's sort of re-architected to run 5G, but it can also still run 4G. So we could run 5G networks as well. It's just that for deployments, it's better to use off-the-shelf hardware. So we'll stick with 4G, but future projects might look into also 5G. Okay, next slide. So as I said, the principle is for moving the core network to the edge to allow for disconnected access. And also this might give you, other interesting characteristics to play with. So in the urban case, maybe you don't have flaky connectivity back to the internet, but what if your organization has privacy needs and wants to keep all the encryption keys for the network on their premises? And what if they wanted to put up the network themselves without even having to go through us or give us any trusted information, et cetera, et cetera? So this decentralization may still be useful for the urban case. So we have a number of projects, research projects in the lab around decentralizing LTE. So we wrote a paper called DLTE, which is more of a concept paper about maybe you could remove authentication entirely from LTE networks. And then we also have a project called DAuth, where we allowed roaming between independent networks, essentially distinct EPCs, by setting up a federated blockchain between them and sharing one-time use authentication tokens, so that users can seamlessly roam between different core networks. And this is implemented. And we also have an ongoing project called DX2. The X2 is just the name for the interface between 2 of the radio base stations, or eNode Bs, the part in the green box. And the DX2 project will hopefully enable handover, just as if 2 of these base stations were in the same network. You can move a phone from one to the other seamlessly, even though in our architecture they're on different core networks. Next slide. Okay, so what does this look like in the physical world? You can have block diagrams everywhere, but what does it really mean? So we have our deployed network, which is it was on the roof. I had to actually deconstruct and deploy it, but we're going to set up another test network exactly like it. So on the right, that's just a large omnidirectional antenna and our radio, which is a radio that runs in the Citizens Band Radio Service, CBRS, frequency band of 3.5 to 3.7 gigahertz, and I'll explain more about that later. But it's a very small number of components. So we've got our antenna, our radio, and our mini computer running Ubuntu 18.04, which is what the Open5GS software currently runs on. And this, so in the red box here, that's what our core network runs on. And the core network software can actually just also run on a Raspberry Pi 4, which was very exciting because it cuts down the cost of our compute a lot. So then, we've got our user access device, which is just a smartphone. There's actually a caveat where the smartphone also has to use the Cbrs frequency spectrum, which means that we can only use kind of newer phone models. But yeah, and that's a limitation based on the frequency that we are running our networks on. But this is it. This is like the whole network. Next slide. So around last year, we heard that there was a new regulation by the FCC about the ability to run devices in this frequency band, the Cbrs, Citizens Band Radio Service band. Normally, you can't just run a cellular network. Like, you need a frequency license, which is why the telecoms pay billions of dollars to buy these. And there's this new open access band where you can sign up with something called a spectrum allocation service, and it dynamically allocates you the spectrum for your particular device based on what else is transmitting. And then they have different tiers of access where the telecom can still buy priority access. However, if they're not actually running a device in a particular channel of the spectrum band, then general access devices can come in and request the spectrum and use it. So we're using Google's spectrum allocation service. And so we basically have to register our devices and like two, very strict specifications. Like, we have to register, the device type, which has to be approved by the FCC already, the serial number, all the antenna characteristics, so that the spectrum allocation service can actually model everything that's going on and provide this map of what frequency is available. And as you can see in this map on the side, there's quite a bit of spectrum available in Seattle right now because the spectrum has just been auctioned off. So in the future, it's possible that telecoms might come in and start deploying equipment, and then the amount of spectrum available for our devices will diminish and diminish. But for the time being, we're hoping that this won't happen super quickly. So we decided, okay, we'll try to start a Seattle community network and maybe like agitate so that once we already have the network, maybe this is grounds that, hey, this is providing an important service for the public. Like, maybe the telecoms, like, shouldn't be able to crowd us out super quickly. But in any case, we'll cross that bridge when we come to it. We founded this nonprofit called the Local Connectivity Lab, and we were targeting the lower income areas of Seattle, so kind of South Seattle, around the Othello and like Rainier Vista areas. And we received a King County Digital Equity for Vulnerable Adults grant to do a couple of pilot deployments where we build essentially an open access network serving the public, including some of these target populations that they want to serve for the COVID relief fund. So housing unstable, unemployed, majority non-English speaking, and seniors. Next slide. So for our 3 first pilot sites, this is the diagram of the network structure we're envisioning. We want to partner with essentially digital equity organizations that already work with low-income people and and are in these low-income areas. And we will set up cellular sites on their organizational buildings so that you can have like the initial the base station site, and then from there we can have our consumer premises equipment, the fixed wireless equipment, sort of creating an extension site. So we have funding for 3 base stations and then 24 extension sites from there. And each of those sites would receive the LTE service, quite far away, up to maybe a mile away, as in our tests. And they could each also rebroadcast that as a Wi-Fi network. So here I have the consumer premises equipment in blue. Around the cellular base station based at the organization, you have some coverage area for mobile coverage where you can use a phone, and then also Wi-Fi coverage, which is going to be smaller but still can be a block or two. Next slide. And the idea is really to use this kind of as an excuse to build community, especially between tech workers and the broader public, because like I feel that the core importance of this kind of project is to build community. Like internet access, by hook or by crook, you can get it somewhere, but this is really, it's an infrastructure building project. And like from owning infrastructure, there's a lot of power and understanding infrastructure. So the goal of internet access, it's important for sure, but it's also an opportunity to get techies and users and experts and novices together and work to build something and learn about technology in a really meaningful way that serves the public. So the vision for this takes inspiration from the NYC Mesh project and other Mesh projects, where in NYC Mesh you have, I think now they've probably surpassed 5,000 users, nodes, and they have very thorough DIY documentation. I actually worked with them about a year ago now, because I'm from New York City. So I volunteered with them a lot when I was there, just staying at home for a while. And they have a really, really active and engaged community of practice where, you have a ton of tech people and a ton of people who are just like, wow, this seems cool, who are, learning and being onboarded. And, neighbors are truly able to support neighbors via, in-person like help, and also the Slack group. So you've also got neighborhood-based support channels, and you've also got, essentially community governance. They have a meetup. They meet every month, and they, get funding through communal effort, and they also have a suggested donation-based funding model so that people who can't pay don't have to pay. So in my opinion, building this community of practice is really going to be the task here. You can't just have one type of person involved in this kind of network. You really need a large base of tech workers, because otherwise, one technical problem comes in and like the network goes down forever. But without like a large base of users, it becomes kind of a circle jerk of tech. Like it becomes pointless. And you also need like active teaching and onboarding of novices, which is a good opportunity for community outreach and tech education. Next slide. So, there are many possible roles for community network contributors, and they include, but are not limited to, climbing on roofs and actually doing the construction of the network, which will hopefully happen 1 to 2 times the next few months as we install our planned 3 base stations. Helping install software, configuring equipment, writing useful scripts and utilities. So this is coding and Linux sysadmin stuff. So site search and surveying and network planning. This is a surprising amount of work. It's like, you know, every time you you have like a new possible partner, you have to map them and try to figure out if there's line of sight, and walk around in the neighborhood and think about, you know, who could connect to who. Yeah, there's also helping with community organization, partnership. So, you know, emailing and calling and figuring out, hey, like, do you want to be part of this? Do you have, you know, members who would be interested in participating? And, you know, are you able to give us access to your roof space? Things like that. There's also eventually going to be teaching of technical skills and knowledge, especially for kids. You know, gotta bring in more kids to computing, and seniors who have a lot of trouble with particularly using the internet. There's also, you know, community technical support, which it's not necessary yet, but once we have a lot of users on board, it will be. And finally, donating bandwidth. That is one of our huge pain points right now. We are working with the UW and the city of Seattle to get some donation of bandwidth from there. We're kind of stuck because of it takes so many months to organize between all the institutions that are involved in any kind of UW and city endeavor. So yeah, we're basically hurting for bandwidth right now, and we're also kind of hurting for roof space. So those are the two big asks that I've been making a lot to community organizations, and it just requires a lot of work to get them on board. So finally, grants and getting funding. Although we have some initial funding now, that won't, you know, get us past our first few pilots. Next slide. So our current partners are the AltSpace Makerspace in Central District, REWA, the Refugee Women's Alliance, the Southeast Seattle Tool Library, the Filipino Community of Seattle, and in Tacoma, the Tacoma Cooperative Network, and Althea. So Althea is a mesh routing technology, and that essentially supports the Tacoma Cooperative Network, and that's part of our efforts in Tacoma, if anyone's interested in working there. I focus most of this talk on the work in Seattle, but there's also, you know, an active effort in Tacoma. We have our first deployment there, which I talked about in the blog post that was probably shared out earlier. Yeah, next slide. And we're definitely recruiting more organizations. So if you know anybody who would be interested in such a project, who are already interested in digital equity, I have been getting some emails, and so we're actively recruiting. Next slide. Oh, back one slide. Yeah, so this is the actual last slide. The other slides are backup slides. So this is my contact. LCL@seattlecommunitynetwork.org is our the nonprofit email address. So please email that with any, you know, questions, or if you want to be added to anything. My personal email is infrared@cs. We have a Slack group, a Google Groups email list, and this is the link to my blog post. So thank you.
Thanks, Esther. That was really cool. I'm super inspired. I didn't know about the new Cbrs ban. I was wondering about that. That's really cool. I haven't yet looked at the questions. I was wondering, Jim or Cameron, would you maybe want to do moderation of questions?
Yes, I can help with that. So personally, I actually have a question for Esther. So this might be explained by some of your later content, but I was wondering, when you talk about the urban use case for this community network, if it's driven by things like LTE, like in the 4G band, would that run interference with other, say, big telecom frequencies?
Right. So for now, no, because as I mentioned, we're using the Cbrs 3.5 gigahertz spectrum, which currently the telecoms don't seem to be using. So there were licenses, I think like priority access licenses for Cbrs that were sold earlier this year. But so far, there haven't been really deployments. As you can see from the map on, I think, slide 8, the spectrum is basically open right now because it doesn't have high adoption. You can run all sorts of protocols in this band, and LTE is only one of them. So, you know, maybe they'll want to run 5G protocols in this spectrum band eventually, but for now it's wide open for us. Yeah, we'll see how that changes later. I'm a little bit pessimistic that maybe they will try to, you know, encroach upon the space within the next 5 years, but it depends on maybe where. Like in the most dense urban environments, there will be you know, other carriers there, but in like the low income or sparser, less profitable areas, maybe there won't be. And that's our target.
Thank you.
I have a couple questions. Just curious, how much does it cost to set up and maintain one of these cellular base stations?
So since we're using kind of off-the-shelf base stations, these are, you know, they're like commercial outdoor equipment. The ratings on these like tend to go for, you know, 25 years expected lifetime. Like they're hardy devices. The computers that were the mini computers, not so much, but those are cheap. And the base station is probably our highest cost item. It's probably around $3K. So that's, and then you've got the antenna cost, which can go for a few $100s. So our total install cost for everything is usually around $4K. For a cellular site that can serve, you know, 96 simultaneous users, this is not bad. And like you also get, of course, the increased range and everything. But it is more costly than like a Wi-Fi mesh node. So it's really about the kind of engineering trade-offs that you want to make. And I think for us, we were going for, okay, well, like, you know, this Cbrs band is interesting, and you know, we can cover large swaths of the city. So we're going to try this out and see how it works for community networking.
And what's your maximum broadcast power you're allowed to use for the Cbrs? Is it standard to like similar like handheld CB?
So this is a we're using 1 watt base stations. This is pretty much like on the upper end of what you can use, because for Cbrs, the for this like general access license, you have pretty strict like bounds. So the I think it's total, you have to, like, including the radio plus the antenna you're using, it has to be under 47 dBm per like 20 megahertz, which, I mean, it's basically like 47 dBm. Yeah. And so the 1 watt, like 30 dBm transmitter is basically the one of the higher powered ones you can use.
And you mentioned that bandwidth limitation was an issue. What are the bandwidth requirements? You said, I guess 96 users per tower. So what are your bandwidth requirements for one of these cellular base stations?
Well, so each user actually has at least with this space station, it has a max rate of like 112 megabits per second. So, you know, it would be nice to have a gigabit basically feeding our base station, or, you know, however, yeah, just like a large pipe, it would be nice. But of course, you can share a connection with like a lower rate per user. So like I would imagine it would perform okay with maybe 300 to 500 megabits. And even 100 megabits. Like, so for context, in the rural remote sites that like in Indonesia, they're running off of 3 megabits and they're sharing that amongst their entire network. And that's okay. It's not like super, but it's okay. Yeah.
I'm just curious, what are your thoughts on the Starlink network? And I think those are getting like 80 down in rural Washington. Any thoughts on the Starlink network and possibly pairing that with these cellular base stations?
Yeah, I think, I mean, that is the hope, because once you can get Starlink everywhere, then, you know, you can get that in the rural areas and it's going to be more affordable. However, I mean, a lot of us in the lab, like, we kind of doubt that Starlink will provide coverage everywhere. Like, yeah, most of these projects, they're like, oh yeah, we're gonna provide coverage everywhere, and then they end up covering like a small section, like above, you know, one country. So it like remains to be seen where Starlink will be available, and that's really kind of like in all of these, you know, equity type situations where you've got, okay, these people are unconnected. They're usually unconnected for a reason. It's because it's not profitable. So yeah, that's like a high level. I mean, I think that it's like satellite internet being like much cheaper and much more widely available will be excellent in the future.
All right, one more question and I'll stop by. I was just curious if you're familiar with the Helium network, and you mentioned that you had 2 of these networks that were separate connection. I believe you called it roaming, the connection they had. Any thoughts on the Helium network and potentially you know, creating like a decentralized cellular community-based service?
I actually haven't heard of this. I just looked it up. It looks like it is a blockchain network. There are, you know, a number of blockchain wireless networks, but yeah, do you want to just explain real quick, like what's special about it?
So I think I kind of briefly looked into it. I was looking at hosting my own node, but basically you provide bandwidth on a, I think it's a different frequency than this. It's pretty low bandwidth connection for Internet of Things devices. Like you can imagine those little battery powered scooters on the street, like they would use a network like this to communicate rather than cell tower. But basically you mine on the network by providing bandwidth.
Interesting. Cool. Our partner in Tacoma, Althea, is actually also running a blockchain based Wi-Fi mesh where like the routers pay each other for their mesh traffic. But yeah, it's definitely more on the home router scale, not like, it looks like they're using one of those low power, IoT protocols. Low raw WAN. Yeah, so they're all kind of different use cases, and yeah, this like the cellular side is just totally different. It's like a totally different, you know, architecture and hardware and frequency and everything. So, but I think there can be a really interesting like ecosystem of all of these types of networks. Like our project in Tacoma is going to combine our network with the Althea network. So we'll have, you know, the Althea network providing kind of the billing solution so that you can set up LTE links, like someone can have an LTE base station on their house, but they can also use the Althea like paying each other structure to pass traffic and like have a LTE in the mesh. Yeah. Okay, so there is.
Oh, sorry, not to interrupt you. We had a question in the chat from Mitchell Harper asking about where you're sourcing eNodeB's base stations from.
We're using the Bicells ones. We have a pretty good relationship with Bicells because they have a good relationship with the Internet Society, and the Internet Society supports us a lot. So yeah, the Internet Society is a nonprofit, like global nonprofit that basically supports, internet access throughout the world. And so we kind of have like contact and sort of lower prices from Bicells and like pretty good support from them. But it's also that they are kind of the cheapest option on the market. So once there are, other eNodeB options, we would definitely look into them. Bicells is a Chinese company. And I see another question from
me.
Yes.
Which is, I'm really curious about, so you mentioned that the citizen band radio, or the citizen CB something.
Cbrs,
the spectrum.
Yeah.
The citizen band just opened up. And I'm really curious about the politics around that. I'm wondering, like, I don't know, this isn't a clear or good question, so feel free to pick whichever part of this you'd like to answer. But I'm curious if you know why it opened up, like what the motives were around it, and then if the telecoms are allowed to reserve space just like other folks, if there's anything that would sort of disincentivize them from doing it, or if that's just something that might happen, like that's very interesting. And then there's also like the question around if you're going to start to make an argument that the citizen band is important to protect, it seems really important to have public metrics around who's using it and for what purposes. But I'm curious if any of that information is publicly measurable or publicly accessible.
Yeah, it's really interesting. So my understanding is that people have been agitating for, or like, yeah, essentially advocates for this kind of management of spectrum have been agitating for a long time for a dynamically managed spectrum, because the fact that telecoms are able to have national licenses that cover all these areas that they don't actually provide coverage in is crazy. And it's like, it makes the government a lot of money, which is why it's been so hard to not do that. But yeah, people have been agitating, like technologists have been agitating for dynamic spectrum allocation for a long time. And I'm not sure what actually like galvanized this to, happen, but the idea is definitely to allow, more innovation, like, and also like private LTE networks and yeah, more innovation to allow products to develop in this space. And so yeah, it actually has provided a lot of opportunities already for, this open source project to become, a real network in this case. And like, it would be great if spectrum could be, used as a natural resource instead of just like sold off in large swaths. So, I mean, I think that it's a result of a long time of like lobbying, essentially, of like, yeah, of advocating. And I think ultimately, like, the telecoms will probably move in and like deploy other networks in this spectrum. But I guess the idea is like, if they don't end up using spectrum in a particular area, like, why not allow open access licenses to be given out? Yeah. And I think it is a better solution in terms of equity. Like, you know, there will always remain areas that are uncovered. Does that answer your question? Because I feel like your question was very complicated.
Yeah, I mean, it does, and it is a long question. The only other thing is just sort of getting metrics around the use of it. Like if I were trying to build an argument that says, hey, we advocated for this and now we're using it and it's amazing and it's enabling all these things, like I'd need to actually know that. But it seems very likely to be a lot of distributed open source projects that are by themselves already plenty of work to run. So I'm worried that that kind of data is just kind of gonna kind of like slip through the cracks and not be where it needs to be a political argument.
Yeah, I think this project could be part of such an argument. Like if we do end up, you know, covering some amount of area of the city, we can say, hey, look, we're providing this service. Like this is actually doing good for the public. Yeah, it's true. It is already open to the telecoms. Like it was auctioned off just a few months ago, I think. So there's like a tiered access structure. Like if you have a priority license which you've bought, then you can transmit using your device, and it all has to be entered into the same like Spectrum database. But if my device is on there and it's like a lower tier, like general access device, then it gets kicked off and it gets hopefully assigned a new channel. But you know, the priority devices get priority. Yeah.
That's really interesting. I realized that us as hosts, we've been asking a lot of questions. I want to make sure we reserve a little bit of space, make sure that other folks have a chance. If anyone has a question and they'd just like to ask it verbally, feel free to unmute yourself and ask.
I'll go ahead. So you mentioned that right now there's dynamic allocation, and I'm curious what the frequency is for turnaround on when a license might be prioritized. Are we talking like on the order of milliseconds, on the order of like days? Just kind of curious.
Minutes. It's a few minutes.
Okay.
Yeah. Okay. I think it's supposed to be 4 minutes. I'm not sure exactly that's what's implemented, but yeah. Yeah.
So how often do those auctions happen?
Probably once every 10 years for a given. Yeah, the situation is dire. Like the longer the license can be sold for, the more money it can go for. So
Yeah, for anyone that's interested in those auctions, there's actually great on NPR, I believe it was Planet Money or Radio Lab, had a really interesting episode in the last month or so on how those auctions work and kind of the history behind them.
do you want to like post, do you have that link? Can you post it in the chat?
I will find it and post it.
Are there any further questions? Well, I really appreciated that, Esther. That was a fascinating talk, and I'm so glad I had this this meetup to invite you to have an excuse to have you give that talk where I could listen to it. I hope everybody else enjoyed. We will make this available on our YouTube channel, and we'll link that from the meetup event when that goes out. We also have our next meetup already scheduled, although not yet fully announced because we don't have all the details yet. But as some of you likely know, Filecoin had a big launch this fall, and their product lead Pooja has agreed to come speak to us on December 17th. So there's a little stub of an event up on Meetup, and then I'll fill it out with details and properly announce it later on. Any further closing comments from you, Jim or Cameron?
I guess this will be as good as time as any to open up the community minutes to everybody in the attendance. If you have something personal project, interesting thing that you found that's related to decentralized web, feel free to plug away.
I guess I'll go. Again, my name is Mitchell Harper. Grad school, or not grad school, but graduate of the Allen School, right when it was changed its name to the Allen School. And I currently do work with a group that's sort of trying to do some organizing around municipal broadband on every front possible, at the city level, at the county level, working on potentially trying to change regulations at the state level that might allow for more options for publicly owned broadband. And there's an ongoing working group, and I can probably provide details in the Slack or here if anyone would like any, but we're working on a lot of different fronts with a lot of different community groups, also some engaged in internet equity right now, and getting connected with them, and to try and see what is possible, because the pandemic has made it really clear. I think it sort of was a wake-up call for a lot of us how stark the disparities were, and now is sort of the time to sort of capitalize on that need. So the name of the working group is Share the Cities. There's a Twitter. There's a lot of organizing that happens under Share the Cities in Seattle. But the Twitter handle is Share the Cities, and I can also give you my personal email address if you'd like to get connected with that working group. Any questions on that? I'll put my email in the chat.
Thanks, Mitchell. That's great to hear.
All right. Thanks, everybody. We're coming up to the close of the hour. And I'll leave this room open until 7, just in case anyone wants to go find links from the chat. I'll put a link in our meetup event to Esther's slides so that you all can see and check through. There were some links in them. And then there's also, if you scroll up, I did paste how to join their Slack and everything. So thanks very much for coming. I really appreciated the talk and all of your engagement.
Thanks so much for having me.